So this is AI for Communities, hosted by San Mateo County Libraries, as well as Women in AI Ethics. I am Mia Shadan, your presenter for today. I am the founder of Women in AI Ethics, and our philosophy is simple. We want to make AI more diverse, ethical, and inclusive. And the way we do it is by elevating voices and work of brilliant women who work in this space. You can find more information about us at womeninaiethics.org. Just so you know, this is a hype-free, shield-free zone. I do not work for any tech companies. I do not represent any tech companies, no tech vendors. So whatever you hear from me is pretty much designed with the community in mind. And that's always been our approach, to be credible sources of information for our community, but also making sure that we are always keeping our communities at the heart of everything that we do, which is including development of technologies and how we deploy technologies. So that said, I'm so happy you could all join me here today. So let's see if we can just move this bar out of the way so you can see my screen. So Introduction to AI and Algorithms is the first session in the series of 3. The other 2 are, the reason we are starting with AI and algorithms, because it is in the news a lot, and it can get sometimes very challenging to figure out, is this real, is this fake, and what's going on? So the GIF on the screen, which seems to be lagging, is from Wizard of Oz. And you might remember, the wizard is just an old man who's behind this green curtain, and you think it's magic, but it's not. So artificial intelligence is somewhat like that we think it's all magic and myth because the way it's presented in the media. So today we are going to debunk a lot of this myth, and we are going to demystify algorithms. We do have 2 more sessions coming up. Next week, same time, if you have registered for one, you're registered for all 3. So next week is generative AI, good, bad, and the ugly. I'm not going to teach you how to create a perfect prompt. This is not a prompt engineering class on how to use generative AI class. It is more of an introduction to what is the basic concepts, how do these things work, how can I use it, what does it mean for me, what are the tools out there. So we'll be talking more about how and what of the technology and the humans behind it. And then keeping yourself safe. This is the most underrated topic, I feel, in artificial intelligence today. We do not talk about it enough. Is how can you keep yourself safe in this age of AI, from deepfakes, from disinformation, from fraud? How do you protect yourself when AI is threatening to displace you? Maybe automate away your jobs. So these are the things we should be all concerned about. So in 2 weeks, we will have an open and honest discussion about this. We will talk about where we are with AI, and then how can you get the tools and the resources to keep yourself safe. So that said, we'll get started with today's session. So here is the layout for today's class. We'll start with an introduction. Actually, we are done with the introduction. I've introduced myself, introduced the session. History of computing, we'll start there. We'll talk about whether AI, let me go back. Can AI machines think? Where did it all start? Folks seem to think artificial intelligence just came about 6 months back, or maybe a year back. That's not true. Artificial intelligence has been around for a while in different shapes and forms. So it's been an evolution. So we'll talk about it, what that evolution looks like and where we are today. Then we'll talk about the AI boom. What's leading to the hype, and why is it in the media so much? How did we get here? We'll talk about that. We'll talk about how we demystify the algorithm. We'll look at the ethics of AI. We'll talk about, okay, what is the harm? What are the harms? What is the hype of AI? And the last but not the least, I will recap everything that we've learned. Don't worry, there's no quiz. But I will leave you with a lot of resources so that you can continue the learning journey on your own. Every day, the space just evolves, and there's new developments every day. So what you learned 6 months back may no longer be relevant. I just came across a great paper just this morning that I'm going to share with you in the resources, which basically debunks a lot of things. Another paper that came out last month. So stay tuned. I will leave you with resources. You can, again, catch up on a lot of these developments on your own time as well. So the history of computing. So here's the part, like there's a lot. This is a very brief history and timeline because we only have an hour with 15 minutes of Q&A. So just bear in mind that we will go fast here in this section. But if you have any questions, of course, I'll stick around later so that I can answer them. So if I say computing or computers, it conjures up images of a device, right? You're thinking, okay, it's got to have a keyboard, it's got to have a monitor, it's got some processors and so on. But did you know original computers were human? They were devices. And this is what the original computing device looked like. This was back in the 1800s. Charles Babbage was the one who created an analytical engine. He also created a difference engine. One was a specialized calculator. In those days, you had to do a lot of this work manually. So right now, if I said, tell me how much is 112 multiplied by 2001 or whatever, right? You are going to pick up a calculator unless you're really good at math, unlike me. Maybe you know that answer, but in those days, you didn't have a way to just take your phone out and start doing the calculations, or you don't have a calculator. So he developed the first mechanical calculator for producing some of the mathematical tables, scientific tables. But he also created the first computing machine, which had general purpose capabilities. And the funny thing is he did not get to finish a lot of his plans. He had a lot of plans. He never actually got to build them. So his son finished some of them, and also the museums where some of these machines are hosted had to finish based on his design. But that was where I would say it's all first started. But then Ada Lovelace. Ada Lovelace was the daughter of Lord Byron. So if you're know anything about poets and poetry, if that's your jam, she was the daughter of Lord Byron. Yes, the poet Byron, and she was. Her father was actually disappointed that he didn't have a son, so they didn't have much of a relationship. But she was every bit as brilliant, and maybe even more so. She was a mathematician. She was an inventor. She was a visionary. She saw the possibility of Charles Babbage's machine to be used as more than an analytical engine. She also remarked that it could perhaps be even used for creating music. She was the original programmer and definitely way ahead of her times. Then there were the Harvard computers. Now, this is at the 1800s to 1900s. There was a team at Harvard, at the Harvard College Observatory up in Cambridge, up where I am, up north in Massachusetts. And these were the Harvard computers. These were women who used to take all the astronomical data, and then manually they used to write down and document a lot of those observations. So those are your Harvard computers. Then we come to the 40s. There are the NASA computers. You might remember there was a movie, The Hidden Figures, about how there were so many women, especially Black women, who were working at NASA. They didn't even get half the credit that they deserved. Like, they didn't get a lot of credit at all. But they were mostly female employees. There were a lot of female employees at NASA who used to do all the work of the computers. They used to take a lot of the data, and they should transcribe a lot of the engineering, raw data into engineering units. So that was their job. If you're wondering why human computers played such a big role in World War and World War II, I just have one word for you. It was the draft. In United States, women were not allowed to go to war. So they were back while men were overseas fighting in the war. There was a labor shortage. So women stepped up. There were a lot of them with mathematical degrees in mathematics. And so they went to work and they became the human computers. And they are responsible for a lot of development you see and advancements you see in this field. However, the wars ended, men came back, women had to go back home. And by the 1990s, this space, which is now basically as you see is now dominated by men. So moving on. Also, the work that we do at Women in AI Ethics is about elevating voices of all the people who have been invisibilized by the industry, by the tech industry. So in 46, that's another example how that happens. Is there were 6 women who programmed the first general purpose digital computer. And there was a press conference hosted because this was a huge deal to imagine, like back in those days, have it being introduced to your first digital computer. They did the programming, but they did not get any of the credit. So when the journalists showed, they were shooed away, and the credit went to the man who basically managed this project. So that said, moving on. So how did we get from computing, doing all the manual computing, to AI and artificial intelligence? Where did that start? So in the 40s and 50s, a group of scientists from all different backgrounds, there were physicists, there were engineers, there were computer scientists, there were also psychologists. They all came together they started talking about the concept of an artificial brain. The possibility, could we create the artificial brain? So the inspiration, if you think about it, for artificial intelligence is really humans. I feel like we underestimate our own power and how unique and special we are, because the way we've been taught is technology is supreme. But if you look at across the board how technology has evolved, especially artificial intelligence, it has been mainly inspired by the human body, by the brain. So this was the first instance. So in 43, as talks progressed and work in this space progressed, an artificial neuron was developed. It was called a perceptron by 2 scientists, Warren McCulloch and Walter Pitt. So they proposed this idea that there could be a computational model of the neuron, which basically are the little cells in your brain that help with the processing in the actual human brain. So in 57, we all stand on the shoulders of giants, right? So every generation just builds on what the previous batch of scientists had built. So in 57, Frank Rosenblatt took the concept of the perceptron further and created the algorithm. And we'll dive deeper into algorithm. We'll follow along just the history right now, but we'll talk about what that means and what that looks like. But that became the basis back in the 57s of the neural networks. Like that became a methodology for training neural nets. We've come a long way, but this is where it all started. Another programming pioneer, you might have heard her name, Grace Hopper. Her contributions to the space are enormous, but suffice to say, she's not only a pioneer computer scientist, she was also a naval officer. She became one of the first programmers of the machines that I shared with you, which is a Mark I. She was the first programmer for that machine. And there are so many more. I could do an entire class just on her contributions alone, but we only have an hour, so I'll keep going. So here comes a seminal question. Can machines think? You might remember there was a movie that came out, the Imitation Game. Benedict Cumberbatch. It was about Alan Turing. Now, Alan Turing was a mathematician. He was a British mathematician. He was best known for helping the Allies win the war by breaking Nazi ciphers during World War II. And there were many women involved as well at the Bletchley Park. And so again, we'll keep going because we have only so much time. However, he also came up with the Turing test, which is the test for determining whether or not a machine can fool a human into thinking it's a human. He did publish his his thoughts in a paper called The Imitation Game, hence the name of the movie, Imitation Game, and he poses these questions, and I have a link in the resources. Do read it. It's fascinating. This was in the 50s, and in thinking about like how can we determine, it's philosophical, just so you know. This was published in the Magazine of Psychology and Philosophy. It was not a technical paper per se, even though he was a brilliant mathematician. He was also very thoughtful. So he did not actually believe the machines could think, but he was posing a questions as to what tests we would need to determine the intelligence of machines. Again, highly recommend the paper, link is there. Please do read it. I think you'll find it very fascinating. So here's where I'd like to take a pause and get a little bit away from technology and talk about the human behind these technologies. Alan Turing is very well known, renowned, right? There are awards under his name. However, did you know in the 50s, his own government prosecuted him because he was homosexual, and it was illegal at that time, and it still is in many countries. And he accepted chemical castration in lieu of going to prison, and he ultimately committed suicide. And it's such a tragic loss. I imagine the advancements that we could have made. Imagine what we could have achieved had we had his government been more tolerant. But again, it's a reminder. We get so carried away with technology that we forget the humanity of the people who are responsible for those advancements. So in 56, okay, artificial intelligence, how did that phrase get coined? It was in 56. It was at a Dartmouth conference in, again, New Hampshire, up north from here, where I'm based. That's where this phrase was coined about machine learning. The study of the field of study was then developed. The concept and the field was developed back, formalized in 1959. But this is gentleman, Arthur Lee Samuel. And the field is defined as the one that gives computers the ability to learn without being explicitly programmed. So remember when we talked about all these original programmers, it was a manual process in a lot of cases, but now you have machines that can actually program themselves, don't need explicit programming, but they can also self-learn. So the first machine that he created, the first self-learning program, was the checkers playing program that he created back in the day. So talk about motivation, right? So here, natural language processing, you'll hear that a lot because anytime you think chatbots, ChatGPT or any form of chatbots, just remember a lot of that is built on natural language processing. In the 60s, there was a program at MIT that was built called ELIZA. And ELIZA was the earliest example of a chatbot. And here's the thing, I always thought ELIZA was an acronym, but it was actually named after Eliza Doolittle. I don't know how many people know this. There's My Fair Lady. It was a movie. It was a movie, and then it's also a musical. It's about this unsophisticated poor match girl who is a sophisticated professor takes under his wing and teaches her to be more like ladylike and sophisticated. So that was the thinking behind, I think, psychologically naming the program ELIZA to make it a more sophisticated language processing system. So moving along. The second wave of AI was all about expert knowledge system. It was a lot of gameplay. You might remember, again, I'm at the risk of dating myself, but in the 90s, if you were around then, IBM's Deep Blue. IBM was a pioneer in this space. Like right now, we don't hear a whole lot. We hear about Google and OpenAI and others, but IBM was a formidable force in the 90s with their expert knowledge systems. They built the first chess playing system, which defeated the world champion at the time, Garry Kasparov. So now we talked about like how we came about, like how did artificial intelligence come about? Let's talk about the boom that's happening right now, why you're seeing it in the news so much. So here's what happened. So at the heart of the artificial intelligence boom right now is deep learning. And we'll talk again, we'll take back the curtain, we'll dive deep, and we'll look under the hood and we'll test everything, we'll look at everything. But all you need to know right now is the advancements in AI were because of three key developments. One is algorithms. Algorithms became more powerful. We had a ton more data available. And computing power really got very much more. We have like massive computing power. So let's talk about the data for a second. Let's start there. Like, where is all this data coming from? You might remember back in the day, again, I'm sure most of you may not remember, but the internet hasn't always been around. it was in the 60s that ARPANET was first created. And the map you're seeing on the right is how the first universities were connected. MIT and those of you in California, UCLA, I believe, was one of them. Rutgers was another. So all of them were connected, and that was the original ARPANET, which was just connecting a handful of universities and the government. As much as and then in the 80s, there was a TCP/IP protocol that was introduced. But the bottom line is that became the foundation of the internet. Then in the 90s, you've got the World Wide Web, thanks to Sir Tim Berners-Lee. And in the 2000s, everything exploded with broadband, and then we got social media and so on, and people just started posting data everywhere, right? You have photos, you're posting tweets, you're sharing your personal data, your status updates. So all the data started getting out there, and it's on the internet, right? All public. So here's where it gets very interesting. So Dr. Fei-Fei Li, who is now at Stanford, was originally a junior researcher at Princeton. She started working on this idea of ImageNet. Now, ImageNet is the gold standard of data sets. And you'll see why it becomes important, because data is what fuels a lot of artificial intelligence. So she started working on this in 2006. Took her 3 years. And today, it's much bigger, but the last I checked, it was 14 million images in it has over 20,000 categories. So it's a massive image database. So how did they gather it? They hired a bunch of, she assembled a team of researchers, and they hired a bunch of freelancers through Amazon Mechanical Turk. These are a bunch of freelancers, contract workers, and all over the world, who work for pretty much minimum wage. They take all these images and they manually label them. And this is how you turn up with this massive database. And that became then the basis for a lot of image generating system AI models. So we'll keep going. So computing power just exploded. Now, by 2019, graphic processing units had AI-specific enhancements, and they had replaced the central processing units that we have in computers, which basically meant, bottom line, without getting too technical, is the amount of computing, the amount of data that you could process, and the speed that you could process it at just blew up exponentially. So if you have kids, or if you're a gamer, you're pretty familiar with this, because the price of these because you use these graphic cards, the GPUs, and the external, the GPUs and the graphic cards, you use it for a couple of different applications. One is gaming. So a lot of gamers are familiar with it, but then it started also getting used by the miners, right, for cryptocurrency mining. So some of you might remember the price of these graphic cards have been up the roof because they became so expensive. That is basically what's fueling a lot of artificial intelligence developments and advancements. So then we talked about, I told you, right, there were 3 things: data, computing power, but last but not the least, a lot of the algorithms became more powerful. There were new architectures that started coming out in every paper. If you're wondering what AI researchers does or what they do, this is what they do. They do a lot of these, they're responsible for a lot of research that goes into development of these new architectures. GANs are very important for you to know if you want to learn about artificial intelligence. And here's why. When Ian Goodfellow, he was, I believe it was at Google at the time, and he and his colleagues wanted to generate images. So he used deep learning to generate images. So he was the one who came up with the concept of GANs. And here's one example of an image. This is not an actual person. This is a synthetic image. This is a fake image of a young person using a GAN, which is a machine learning framework, which is used to create synthetic data, fake data, if you will, and based on the data it's fed. So next week, I will talk more about generative AI, and we can dive deeper into how these are generated, what are the different examples and tools, so forth. So stay tuned. So we will keep moving along. Again, this is basically just to give you a solid foundation in artificial intelligence. There's not going to be a quiz, so don't worry about it. You'll get the slides, you'll get the recordings, so you can review at your own leisure. But let's talk about GPTs and LLMs. Again, super important because we keep talking about ChatGPT, but what is this GPT and what are LLMs? In 2017, a bunch of researchers at Google, and none of them are at Google anymore, but at that time they were at Google, and they published a paper. They called it "Attention is All You Need." They introduced a new architecture, Transformer. Now, this network architecture is now the basis for natural language processing. What it did was it made a lot of development of this artificial AI systems faster. So you could process faster, you can do a lot more work with these models based on this architecture. So this has become the foundation for GPT. So if you're thinking why the boom now and what happened, and this is basically one of the reasons why you're seeing the boom recently. And then it also became the back and for foundation for a lot of LLMs, the large language models as well. So what happened after that was in 2021, you might remember OpenAI and launched DALL-E. Now DALL-E was named cutely after Salvador Dali, the artist, the painter. But what this does is the system based on GANs. Again, now you know why it matters, that you know what a GAN is. But what it does is you can put in a text prompt, like a cute cat. It will generate an image of a cute cat. It's quite revolutionary if you think about it, because it's using the power of artificial intelligence based on the data that is being fed to conjure up these images based on just a text prompt. ChatGPT, again, now you know what GPT is. So OpenAI also launched ChatGPT. So we talked about image generators. Here we're talking about text generator. So you write a little prompt, you give it a prompt and say, write a haiku about a quiet forest, and it will write you a haiku about the forest. I don't know how good it is. Again, technology keeps developing, getting better, but here you have it. So look at the exponential growth that at one point when it started, ChatGPT, when it started, was at 3,000. Like it could only conjure up 3,000 words. But by the time you got the Model 4, which is the latest, actually, I think they're working on 5, by the time they got to GPT-4, this model can actually, this language model can spit out 25,000 words, which means it's an entire novel. You could publish an entire novel from these models. So therein lies basically the promise and the possibility of artificial intelligence, especially generative AI as it's called. But it's not all, like, it's not all positive and it's not all rosy, because it was in 2021 that eminent researchers at Google, Dr. Tim Litzke-Brew, Margaret Mitchell, and other researchers published a paper pointing out that this is great, the possibilities of large language models. It can write an entire novel, and it actually might even sound plausible and interesting, but have you considered what are the ethical implications of these models? What are the environmental impacts? What are the biases that might be embedded? These are so massive, like it can be too big to, fail, and we don't even know what we don't know. So they published that. They were fired for it, and that became the whole controversy. But that's essentially to show you that these, as much as we believe in the promise of these systems, the AI models, they are not without their own problems and issues, and we need to be supporting the people who are speaking up and sounding the alarm on some of these issues that they have found through their own expertise and research. But then Google announced, and this is why, right? Because it's a race to the top or race to the bottom, depending on your perspective. 2023, everyone had raced ahead. OpenAI was launching their own models. Google also decided to jump in, join the fray, and they announced Bard, which was their version, their competitor to OpenAI's ChatGPT. The key difference, I would say, there's one of many differences between the two, even though in theory they are both large language models. One is OpenAI's model is trained on existing data, whereas what Bard does is also pulls in search results as well. So some of the nuances between these different systems that are out there. Okay. So where we are at. So now let's talk about the algorithm. I did promise you we will dig deeper and we'll look at what lies underneath the hood. Let me just check the time real quick. Okay, we have another 20 minutes. Okay. This is essentially, I don't know, my GIFs are not loading, but this is essentially a GIF from Terminator. I'm sure you all watched the movie, but in popular media, you hearing a lot about artificial intelligence, and they're talking about killer robots. Oh, they will become sentient, and someday they'll murder us, and so on. And we hear a lot about that. So what they're really talking about is AGI, or even ASI, which is general intelligence, like very human-like, that it has its own intelligence and it has its sentience, that it is conscious and so forth. But not to disappoint you all, but a lot of artificial intelligence today is narrow intelligence. It's not very smart. It's very task-based. It's very narrow. It can do certain tasks. And these are like very important, like powerful tasks, and it is an important advancement, but let's not confuse the two. Because doing tasks does not require any kind of like ability, like human intelligence or any kind of smarts. For example, AI can learn from data. You put in a certain piece of data, it can spit out answer based on that data. It can complete sentences for you. It can recognize images. It can sort and classify images. It can do a lot, but it's very narrowly defined, not to the extent that's being hyped in the media, and also by a lot of the tech vendors themselves for all the obvious reasons. So what is artificial intelligence? And let's just bring it all together here for a moment so we can all conceptualize what this actually is. So first of all, artificial intelligence is not a thing. It's not something you can just go to a shop and buy and go to a vendor and just, yeah, I'll download artificial intelligence. It is broad. It is the subfield of computer science. It is something that it is very diverse. It has many different disciplines under it. And it is focused mainly on the study and development of machines that can do tasks that require some type of human intelligence, like problem solving, like I said, sorting images, and so on. Machine learning is one layer below. It is a subfield within artificial intelligence. And there it is, as we talked about back in the 50s, when they started building these machines which didn't require programming, that you did not explicitly have to program, do this, then that. It could actually run thanks to the power of algorithms and an advancement in computing technology. The machines could do the work on their own. And it's focused on development again, like I said, the algorithms and the models based on those algorithms, which takes away a lot of the manual work. Deep learning, again, you keep going layers. These are layers. Think of it like an onion. There's so many layers. Deep learning is still within a layer within machine learning, which uses artificial neural networks. So one thing you have to remember, the original neural net is in your head. You carry it with you everywhere. The artificial neural nets are based on that same concept. They learn, they process, just like we do, actually not as well as we do, but they do some amounts. But they can process a lot of these complex patterns from massive amounts of data. And then there are the artificial neural nets. They are inspired by the human brain, like I shared. But you have to remember, when we talk about deep learning is really referring to the number of layers in the neural net. So remember how we said the human brain is configured. You have all these neurons, and they basically they're responsible for their interaction, is responsible for how our brain processes. And there are different layers, computational layers in artificial neural nets, where you can add a lot more complex variables in there, and you can do a lot of sophisticated processing and programming. And therein lies, like, that's what deep learning pretty much refers to. So within algorithms, right? Like, let's jump into algorithms now. We keep hearing this term. What the heck is this? First of all, you pick up your phone, you get online, everywhere you go, they're everywhere. This is not a new concept. Algorithms have been around for a while. Stock markets, even your Instagram feed, are you posting pictures? I mean, the algorithm decides what you get to see first. You don't see all your friends' images or your friends' feed. You go to apply for a mortgage. They use algorithms to decide whether or not you qualify on your phone, everywhere. They're just everywhere. That's basically it. That's the bottom line. But what are algorithms? Algorithms are a way where it's a process for step-by-step, the step-by-step process for solving a problem or doing a task, right? So the way I like to think of it, a non-technical way, if you're having challenges figuring out what that is the way I like to think of it is a recipe. You remember Ratatouille? This guy is just throwing in things. Like, it's more, it's not, you're not just throwing in things. There's a method to the madness. Recipes you have to follow, make sure you have the right ingredients, you follow it step by step. Therein, basic is an algorithm. I'll share with you my cat's decision-making tree. So decision trees are a type of algorithm. They're very commonly used. If this, then that, if you're familiar with that. An example is if you cats, they try to decide, is this for me? So yes, it's for me. Even if it's no, it's not for them, they don't care, it's still for them. But actual algorithms the AI algorithms are computational models. They're mathematical and statistical models that we apply a lot of computing power to. They're basically decision trees on steroids. I'll just take a quick break and just check the chat real quick and see if anybody has anything else. Okay, perfect. Okay, we'll keep moving. Okay, so just to bring everything back from where we started, traditional computing. The traditional programming was input data here at one end, the code at one end, output result. If you have any familiarity with programming, if you've done programming, you might have heard the phrase garbage in, garbage out. That's how traditional programming works. Whatever you put in is what you get out. So the difference between that traditional programming, traditional machine learning is traditional machine learning is based on these different components. And if you missed the part where I talked to you about shared what caused the AI boom, again, reiterating here, data, lots and lots of data that you're sharing, data that I'm sharing, all the pictures we put online, algorithms, and I'll share with you, like, we'll talk through about what these different algorithms are, how they work. But a lot of algorithms go into the machine learning model. Those are then used to either predict things like what's going to happen next, like given this existing data, or you could classify things, you can cluster things. That's your output. This is basically a machine learning model deconstructed at the simplest form. So we talked about different types of algorithms. Let me start you off with the most basic, which is, this is a broad category. Okay, there are lots of algorithms within supervised learning, but basically supervised learning is based on label data. Here's an example. Say you have a set of photos. You have dog photos and you have cat photos, right? So now these pictures are of that, dogs and cats. What you want to do is, and you want the algorithm to sort, say you input an image and you want the algorithm, the AI model, to tell you whether or not this is a dog or it's a cat. So the way it works is you feed pictures, label cat, label dogs, and you pass it through your algorithm. And then you say, okay, here's a picture. Tell me it's a dog or it's a cat. If your algorithm and your model is built correctly, it works, then it's going to tell you it's a cat. Check. It is used, supervised learning algorithms are used in spam filters to decide, is this spam? Is this not spam? So again, the training works in the same ways. The machine learning model is given a set of data which shows it like, this is spam. You're training it. This is spam. This is not spam. This is spam. This is not spam. And again, it's a lot of it is trial and error. It's not like, oh, magical that it just happens right away. Trial and error. It's the same with stock market prediction models. Do they fail? Yeah, they fail a lot of times. But again, over time, they keep getting more and more accurate. Facial recognition is another example of supervised learning. But again, the problem is that it is not perfect. Sometimes when the data has, say, only is trained on white faces, it cannot recognize darker skin faces. So there's one example of bias in machine learning models and where it comes from. Just so you know, I do have a class in 2 weeks, which will be on AI safety, and we'll talk more about bias there. So let's keep moving on. Unsupervised learning, what is that? Unsupervised learning is, here are all these images that you have, but they're not labeled. So this is all purely unlabeled data. So what the unsupervised learning algorithms do, and there are a bunch of them, and what they do is they can find patterns without having labels. So that's how they're designed. For example, now there is a cluster here on the screen. You can see there are dogs, there are birds, there's a hen, a rooster, there's cats, right? So there are mammals and birds. So the algorithm, the unsupervised learning algorithm will just cluster them in all mammals and all birds. And there are different ways you can do it. Again, this is just an example how it will sort through. But the way typically it is used is customer segmentation or image recognition as well. You can use both. And there's no hard and fast rule that you can only use this or that. A lot of times, data scientists use a combination of both or multiple types of algorithms. Last but not the least, we'll stop here because we do have limited time, but reinforcement learning at the basic is, again, I mentioned the trial and error, but this is an algorithm which is trained in the form of rewards and punishments. And I like showing these in the form of a Pac-Man, if you're familiar with the game. It's how it has, you can either get eaten or you can score points depending on what path you take and how well you play. That's how reinforcement learning works. And it is used a lot in gaming. It is also used in robotics to train the robots as to how to operationalize them. So just remember, reinforcement learning is all about rewards and punishments. So this is the last part, and we will, after this, we'll recap and take a break. AI ethics. So AI ethics has broadly 2 categories, but before I jump into that, let me just talk to you about the hype piece. Folks always talk about how, okay, AI is so new and we don't know about it and such, and I've, again, from the beginning of this session, as I've shared with you, it has been around for a while. So in the 60s, as much as people like to hate on the military, the Department of Defense, and the government, and so on and so forth, a lot of funding back in the day for AI, artificial intelligence, came from the Department of Defense. The DARPA was under the Department of Defense. Then ARPA was also another variation of that, ARPANET, that gave us internet. So what they did was, in the 60s, they gave a lot of funding to big projects. One was the Russian to English translation. As you might recall, there was the Cold War going on at that point with the USSR, which is now Russia. So Russia to English translation, they wanted to automate that, and then they also wanted to create autonomous tanks. Didn't go well. By the 60s, there was a lot of overpromising, didn't actually pan out. So then they just canceled funding as it happens. So then again, we try, right? Hope springs eternal. In 80s, try it again. They put in $1 billion in AI. So again, didn't work out, didn't keep up. The results did not meet reality. So again, the results didn't meet the hype, and they had to shut it down again. Moving on. So again, in the 2000s, this is very recent. So when the bubble burst, as you might recall, I have been through a few of these bubbles, and the dot-com bust was pretty darn brutal. So there were a lot of high-profile AI projects at that time, and again, the money disappeared. Machine translation systems were hot then, but then again, there was decreased funding and interest. But again, we are currently in an AI boom. There's no doubt about it. How long will it last? Who can tell? hype also comes in different ways where we think technologies just come in and say, hey, we can solve everything, all your societal and sociological problems with algorithms. That's not how anything works, because there are a lot of problems in our world right now which are not solvable just by technology. And that's where, when hype meets reality, we find that it often does not hold up. But right now we are in the rosy honeymoon period, so everything looks rosy. Is this AI? Another form of hype is when you pretend that something is AI when it's not. For example, I saw a statistic where 40% of startups, AI startups in Europe, do not use AI at all. A lot of AI is also powered by human beings who are doing the work of data labeling, and they're doing a lot of the work behind the scenes. There's not even artificial intelligence, so there was a lot of hype there and fakery. But then harms. Let's talk about the harms for the next few minutes. It comes in many different forms. One is, you might remember in 2020, if you're paying attention, if you had to the news, the tech news at that time, IBM made a decision to exit the facial recognition space because a group of researchers pointed out that their systems are not accurate for dark-skinned people. But later, 60 Minutes, when they ran a segment on racial bias a few years later, they left out these women who actually did the work that got IBM to exit and Amazon to also put a moratorium on its facial recognition systems. So erasure is a big form of harm that happens in the space. When I talked about computing, it was garbage in, garbage out. AI is more bias in, bias out. So the data is biased, the algorithms can also have inherent biases, and you end up with a system which is also biased. So Amazon accidentally invented a sexist hiring algorithm, then they had to pull it back. Then AI bias causes a lot of block mortgage applicants to be denied, and also people who don't come from a lot of wealth and privilege also often get excluded because of AI bias in the systems. Some people, it can be life-threatening too. Because there was a report that showed that a racist algorithm kept Black people from getting, Black patients from getting kidney transplants. I could go on and on, but I have an entire session devoted to it, and we'll talk about it more later. Privacy. Privacy does matter, but somehow our norms have changed so much that somehow we've become more comfortable with this idea of lack of privacy, but not everyone is as comfortable. For example, I find it disturbing that Amazon's Alexa, or even Siri for that matter, all of these virtual assistants, they're always on. And there was a time when Amazon's Alexa recorded private conversation and kept sending it to random contacts in the contact list. And these machines are always listening, because how else do you think when you say, hey, Siri, well, hi, Alexa, how do you think they know that you're talking to them? Because they're always listening. But then the Amazon workers and these systems are not fully automated, so someone has to do a quality check. Guess how they do the quality check? They listen to those conversations. They have recorded these conversations, and that's what they use to train their workers and make these systems better. So there's an upside. Okay, so who owns your data? This is at the crux of every headline you're seeing about companies are being taken to court, and Hollywood artists and film, a lot of the actors are up in arms, and they are striking and so on and so forth, because at the heart of the matter is this question: who owns your data? If you have an image out there, like you've uploaded to any of the social media sites or anywhere on the internet, is it yours, or does the company that is scraping the internet, or the company who owns that platform, is it their data? So it is being sorted out in the courts right now. We'll see how that turns out, but there are a lot of open lawsuits, and there's a growing list of lawsuits that are coming down the pipe precisely for that reason. So I'll leave you with this, the last but not the least, the labor behind artificial intelligence. And this is why this hyper-focusing on technology is so harmful to us, because then we forget the humans that make all of this possible. Whether it's the person, like someone like Alan Turing, or someone like the hidden figures in NASA, or the people who are labeling all these data sets for us. if we are not careful, we run the danger of forgetting and these people, the humans behind the technology, leaving them behind. And you know what, someday that could be you, me, it could be all of us. So I would like to just close on this, that it is important to pay attention, not only to the technology, but also the humans who make it possible. So now let's recap. If we have time, we'll recap. Okay, we have a few minutes. So we will do a quick recap. What did we learn? The original computers were human. Many were women. We've seen how AI is not magic. It can't do everything. It is evolving every day as we speak, but it is an evolution from computing, and we have come a long way from the manual hand coding to not requiring the explicit programming. It has gone through several printers, and I'm sure it will continue to do so, and that's just the nature of things. The current boom is a result of advancements. Remember, data, algorithms, and access to massive data sets that we are providing. Machine learning algorithms have different, like there are different categories of machine learning algorithms. The main ones are supervised, unsupervised, semi-supervised is a combination of both, and then there's reinforcement. Deep learning algorithms are multi-layered neural nets. Think anytime people talk about deep learning algorithm, neural nets, just think your human brain, right? GANs, super important. They form the basis of a lot of synthetic data or the deepfakes that we see out there. GPTs, generative pre-trained transformers. They're also, they're a type of large language models, and they spit out images, they spit out text based on basically the data you feed them. AI hype is a combination of different things. It could be you lying about, like, this work is done by AI when it's not. The over-promising results, that's also a nature of hype. And last but not the least, the harms. Erasure, lack of privacy, like lack of consent. The list goes on. There are a lot. But again, I do want to make sure we end on time. So I will leave you with that. I do have a lot of resources for you. Again, just to remind you, we have 2 more classes in this series, September 7th and September 14th, and we can deep dive into these topics some more. The reading and resource list is pretty much all of the links and resources that I shared with you. Links to all of them. You have a reading list, you have a glossary. It's like learning a new language, right? You might not remember that phrase, but if you're thinking, oh, what was that GPT Mia talked about? You can just look it up in the glossary. It's not a big deal. You just pull it up and say, okay, that's what it means. I also have a bi-weekly newsletter. There is a link. Feel free to sign up. There's no cost. It's absolutely free. It goes out on most Fridays, and it gives you a roundup of everything that you need to know about the space, all the challenges, all the developments, hype-free, shell-free. So feel free to sign up. And that is pretty much it. If you do want to get in touch with me, it's a little hard to read, but I will put it on here. Let me just, everyone in the meeting, if you do want to get hold of me, diversityinai@gmail.com. So you can do so. So thank you so much.